because there's too many other animals in my owner's house. Would you like to keep me? Feels like we're on Sesame Street. Let's bring it back to the valley instead of Sesame Street. I have a new chapter on inequalities. Luckily for me, I'm the math teacher, and an inequality is a symbol and not a scandalous topic for school discussion. So, this first page is a video on LearnZillion, which is great for checking out Common Core type word problems. And because of the type of school year we're having, I just made that an extra credit homework. If you have a homework 0, then you should do that video and submit it to erase a homework 0. Well, I'm just going to start with the other basics, not a word problem, and get into the symbol. And I'm going to get a little scientific and do an experiment here, because math and science are like besties. So, since we're doing inequalities, as in not equal all the time, we're dropping the equal sign sometimes. We're going to do is less than. Emphasis on the word is. This is why we made it darker. We're going to do is greater than. And to tell you the truth, when you guys write them, leave them flat on the bottom, because sometimes it'll be an is less than or equal to, and it should look like an equal sign on the bottom. Is greater than or equal to. So you're going to want to copy this. So often these symbols are mistaken with less than, which mean minus. So 6 less than is a -6 or a -6. Greater than, which means plus. If you're 2 years greater than your sibling, you're plus 2 more years. So this chapter of inequalities comes after equalities or equations because it's harder. And because there's a couple extra things to remember. So we're going to take everything we learned from chapter 6 on solving. I'm going to teach you 2 more things that we're going to discover today. And then it'll be easy peasy lemon squeezy, just like everything else was. So I'm going to take a true statement. This is what you do in a science experiment. Take something that you know something about. I know that 1 is less than 8. Ooh, that sounded a little obnoxious, but I was emphasizing the is. And I'm going to experiment on it. I'm going to take 5 away from both sides. So when I take 5 away from both sides, I get -4 and 3. What symbol goes in between? Now remember, le less is le left. Le less is le left. So if we were going to draw a number line, it will help you know if something is less than or greater than. Because you need to remember that this is negative. It is more to the left of the 3, so less. So I'm going to take another true statement, like something different than the last ones. That way I can discover something new. This is how you experiment. So I took a true statement. 7 is greater than 3, and I randomly decided instead of this time to experiment with subtraction, I'm going to experiment with addition. I'm going to add 4 to both sides. When I do that, I get 11 and 7. If you go to the number line, 11 is more to the right than 7, and you probably were taught with your elementary school teachers that Pac-Man eats the bigger number. Most everybody knows that Pac-Man eats the bigger number, and most everybody points stuff in the right direction. It's when they go to read it that they forget. So remember, if I point to the left, it's less. Left, less. L, less left. Okay, I got 2 is greater than a -3, and I haven't added any negatives yet. So let's try that experiment. I'm going to add a -3. When I add a -3, I get -1 and -6. Now, if you don't use the number line for this, you might get this wrong. Owing me $1 is better than owing me $6. So this number is bigger than -6. Point to the smaller number. -6 is more to the left. -1 is more to the right. So the only last thing I haven't done is subtract a negative, which remember, subtraction's adding the opposite. If I subtract a -6, it's like adding a regular 6. So when I do that to this true statement where a negative 8 is a lower number than a negative 5, I'm going to end up with negative 2 is what compared to 1? It's less. So in my experiment, I've tried everything from adding and subtracting positives and negatives to see what happens to my inequality sign. So in the first one, what happened to the inequality sign? In the second one, what happened? In the third? In the fourth? The point of an experiment is to not have to do this every single time. It's to come up with some hypothesis or conclusion. Oh, I didn't have an hypothesis. I didn't guess what was going to happen. But I can conclude from the results of my findings that when I add or subtract any number, I just keep the inequality going the same way. Nothing changes. Adding or subtracting any number will not change the direction of my inequality. Okay? So, we must move on to experiment room number 2. And we're going to do multiplication and division. So, I take my true statements. They're random, they're arbitrary, but they're true. I wrote true statements of my choice. Now, I'll start by multiplying by a positive. So I got negative 7 is less than 3. I like the number 4, so I multiply by 4. I get negative 28 and 12. How does negative 28 compare to 12? Answer out loud. Negatives are always less than positives. Less, left. Pac-Man eats the bigger number. So I have negative 6, which is a bigger number than negative 9. Owing me $6 is better than owing me 9. So I'm going to do division by a positive now. So I'm going to divide both sides by 3. That would make this side a negative 2 and that side a negative 3. Negative 2 is greater than negative 3. Owing me $2 is better than owing me 3. Okay, number 7. 5 is definitely greater than 2. I didn't multiply by any negatives yet. So let me try that. Oops, I forgot to put my negative in my work. Let me write that down. 5 times negative 2 is negative 10. 2 times negative 2 is negative 4. And if I look at a number line, negative 10 is definitely to the left because it's less than a negative 4. You owe me $10 is worse than owing me 4. And the last experiment will be to divide by a negative. So I take my true statement of negative 8 being less than 4. I divide by negative 4. Remember, this stuff here is arbitrary. But the point is I'm dividing by a negative, and then we're going to see what happens. So I get a positive 2, because 2 negatives will make a positive when you multiply or divide, and I got a negative 1. Your calculator will get your negative signs correct. So 2 is positive, which is definitely greater than negative 1. So let's check it to wreck it. Let's begin. I multiplied by a positive, and what happened? I divided by a positive, and what happened? I multiplied by a negative, and what happened? I divided by negative, and what happened? Now, I don't want to have to say multiply by positive this, multiply by, that's too much words. I'm not into words. If I was into words, I wouldn't be doing math. So the less words, the easier it is to remember. So where did something change? It changed here. When I multiplied or divided by a negative, I flip the inequality sign. Remember, when you take away negatives, you take away groups of negatives, you get positivity. And positivity and negativity are on different sides of the number line. So now if I'm changing sides, then I got to change which way I'm pointing. If I'm not negative and I'm positive now, I'm on the other side. I'm flipping it. Okay, so I always like to say that negativity makes me flip out. Like, you know, people with negative attitudes, they're going to upset people. They're going to make you flip out. Negative, multiplying or dividing only by negative will make you flip out. Add and subtract the negative, I'm just going to keep it the same. All right, here we go. More vocab for you. We're going to do graphing. Okay, graphing just means to draw a picture. It doesn't always have to have a y-axis to it. So I'm just going to draw a number line for this graph, not an x and a y-axis, and I'm not doing a bar graph, and I'm not doing a dot plot. All these things are graphs. Graphs are pictures. Okay, so I have less than and greater than signs. When I go to graph them, I'm going to use an open circle. Open as in hollow on the inside. And then when I have the equal sign on the bottom, I'm going to close the circle so it's going to be filled in on the inside. Okay, so make sure you draw that circle in there. And then when I read from left to right. So if my x isn't on the left, I'm going to rewrite it so that it is on the left. Okay, so let's read this. Okay, here's a graph. Which way is the graph pointing? The graph is pointing to the left. So I am going to write a less than symbol. And the shaded section is where the answers are. There is more than one answer for this. The answer changes, so it's a variable. So I'm going to use x because it's popular. All the answers for whatever x is are here, left of the -2. Now, it's closed in, meaning -2 is also one of the answers. So you don't want to just say less than -2, you want to say it's equal to it also. Less than, everything shaded is less than or equal to the -2. Okay? You can do number 2. You can do other 2. Okay, so I'm not perfect at counting. Number 4 is pointing to the right. Point it to the right. Copy the arrow. Simple, simple. Copy the arrow. Put x on the left. Put x on the left. All the answers in the shaded section are here, greater than the 3. It's an open circle, so the number 3 is not included. So let me give you an example of what we call a solution set. 3 would not be in there. 3.05 could be an answer. It'd be really close. 4 is an answer. 7's an answer. 2,000 is an answer. And positive infinity is an answer. 3.000001 is an answer. A capiche? I'm going to test you when I see you. I'm going to test you. Okay? Is 1 an answer? Nope. It's not shaded. Is 2 an answer? Nope. How about 2.9? 2.9 is right here. Not an answer. How about 2.9 repeating? Can't get any closer than that. Nope. Not an answer. All right? Now let's reverse that. I'm going to give you the sentence. You graph the inequality. So I got x is greater than or equal to 3. So we're going to stick 3 on the number line. How about a couple other numbers? And it equals the 3, so I'm going to close in the circle. Since x is on the left, like I said, and I highlighted and I bolded, I'm just going to go the way it shows. Go the way it shows. DJ M. Rob likes to rhyme. So it goes right, so you go right. Goes the way it shows. All the answers for any number in this inequality are greater than or equal to 3. Like 3. 3 works. 4 works. 3.5 works. 3 and a 10th. I didn't do it in order, but these are just examples of a solution set. Normally I like to write that stuff in order. Okay, so I'm going to go to number 6. I start it because I wanted you to be aware and be careful that the x is not on the left. So if you read this, 4 is less than x. If you go to read it backwards, x is greater than 4. So you have to write it with x on the left first before you can graph it. I am not equaling 4, so it will be an open circle. And now that x is in the right spot, it goes the way it shows. Greater is to the right. 3 is not an answer. 3.5 is not an answer. 3.9 repeating, not an answer. 4 is not an answer. 4 is not an answer. 4.1 is an answer. 4.062 is an answer. 5 is an answer. 2 million's an answer. Whatever, 10 with 1 with 6 zeros. It's a little scientific notation kind of thing there. It's big numbers, point. Okay, do these two without me. And in the bottom, we got some simple inequalities. You still want to do everything we did in the last chapter. Princess X wants to be alone. So who's bothering her? -5 is. So the opposite of -5 would be +5. To the left, to the right. Don't cause a fight. Drop it like it's hot and see what you got. I got an X. Now. I gotta slow down for a hot second here. Sometimes they slow the music down. I added. What did I say about adding? Well, let's look at our notes. When you add or subtract, keep the inequality the same. I didn't write that before, but it's kind of implied. If you want to add that in, add it in. So I was going to the right, or no, I was going to the left before. So I'm going to keep my inequality going to the left. 8, 9, 10, 11, 12, 13. So I put some numbers on a line. It's not equal, so it's open. The X is where it belongs on the left, so it goes the way it shows. I knows it goes to the left, so I shade my arrow to the left. And every answer, including negative numbers, like -72, will work, because -72 minus 5 will be less than 8. You know what won't work? 13 won't work. 13 minus 5 is 8, and 8 is not less than itself, which is why it's open at 13. Okay, so you're going to do number 10. Oh, and you're going to do a whole bunch of these. I'm going to do something more interesting. I'll do number 15. 15 says that -3 is less than x plus 1, which is less than 5. So it's a compound statement. Compound like in English, putting two sentences together. So I'm going to break the two sentences apart. -3 is less than x plus 1, and x plus 1 is also less than 5. So you do two problems. I want to get x by itself, plus 1's bothering it, so the opposite done to both sides of the inequality. Adding or subtracting does not make me change this. I keep it the same. 3 negatives with 1 negative make 4 negatives. X is not on the left, so I'm going to rewrite it. -4 is less than x, just like x is greater than -4. One piece done. Over here, plus 1 is bothering x, so I do the opposite to both sides. Adding and subtracting makes me keep the sign, and that's already on the left. So I got a -4 here, and I got -3, -2, -1, 0, 1, 2, 3, 4. I'm writing all the integers, by the way. That doesn't mean there aren't decimals in between. So I got an open circle at -4. I got an open circle at +4. I'm going to shade greater than -4 and less than 4. Less than 4, greater than 4, everything in between. X is in between, X is in between. No arrows this time. No arrows this time. In between, in between. And just for fun, okay, so this isn't really going to come up ever again. I'm just having some fun. Okay, bear with me. How many numbers in between -4 and 4? How many numbers? Is -3 in between? Yep. How about 0? Yeah. -4? No. -4 is not included. 4? No, not included. How about -3.5? Does that work? Yeah. How about 3.9? Does that work? How many numbers in between? There's an infinite amount of numbers in that space. Think about that. All right. Why don't you try this one on your own? See what happens. You can do it. I got a little simple word problem. Maria's 15 years old. Let A represent the age of her younger brother. if he's younger, what is he to the 15? He being his age, which I'm representing with A. His age has to be less than. So I wrote the inequality, now I graph the inequality. He's not 15, he's less than. Left, less. Alright, so that's all from one little packet. And the next couple packets are just practice of everything I just taught you, but let me do one with you anyway. So I got this this inequality. This is harder than the other ones. You can tell there's more going on. So I go to save Princess Y. There's no simplifying because I simplified before I solve. Now I'm going to do my opposites. Who am I getting rid of? Yep, I'm going to get rid of this guy first because you get rid of adding and subtracting before you get rid of multiply and divide. So the opposite of minus 2 would be plus 2. When I add or subtract, I don't bug out. I leave my inequality. It's still going to stay pointing to the right. And I'm going to copy everything else, which is negative 2/3 y. Oh, wait. 1 and 2 make 3. Oops. Slow it down. Okay. Now who's bothering y? Alright, so in between the negative 2/3 is the times, which is probably how you guys will look at it. Some people treat it as a proportion and cross multiply. Opposite of times is divide by the coefficient, which is negative 2/3. Okay, 3 divided by a negative 2/3. Oh, if I do this old school, we would do stay, change, flip. I'm going to get 9 over negative 2. 2 goes into 9, 4 with 1 left over. So I got a negative 4.5. Alright. Notice, I do know the future, especially when it's my own lesson I'm doing. I didn't write this down.
Students writing groups 8, 7, 3, 1, and 12 may exit now.
I divided by a negative. Whoa. It's time to recognize it's time to flip out. I divided by a negative. I'm not going the same direction anymore. I flipped out. I go left. Star this. Time to graph it. 4.5 would be right between 4 and 5. So to be interesting, I'm actually going to graph it between 4 and 5. It's not including the 4.5. So it's open. And it goes the way it shows because the y is on the left. So I show to the left, I go to the left. Goes the way it shows. They match. The arrows